9.3.2, geometric sequences and series. The objective is to find sums of geometric series. Our key vocabulary is a geometric series is known as the expression formed by adding the terms of the geometric sequence, so just like arithmetic series. The sum of a finite geometric series, which is denoted by S sub n, of the first n terms with a common ratio where r does not equal 1, is the following equation. S sub n equals a sub 1 times the ratio of 1 minus r to the n over 1 minus r. So we're just going to be adding up the terms of the geometric sequences that we were working with yesterday, and that would be called a geometric series. So consider the geometric series: 1 plus 5 plus 25 plus 125 plus 625. Now find the sum of the first 10 terms. So we need to find r, and we know we can find r by putting the second term over the first term. And that would be true for any of those. 25 divided by 5 would be 5, 125 by 25 would be 5, etc. That's why it is a common ratio. A sub 1 in this case is 1. So using our formula, S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. In this case, we have S sub 10, because we're looking for the first 10 terms, equals 1 times 1 minus 5 to the 10th power over 1 minus 5. That actually looks a little bit more like a 16. Let me fix that. The 10th power over 1 minus 5. I would go ahead and plug that into your calculator. It's an awfully big number, 2,441,406. Now we're being asked to find n, so we want to know what position number you are at if the sum of the series, the geometric series, is 3,906. So we're still going to use our S sub n equation that we were using up here, only we now know the sum is 3,906. And that is equal to, well, still 1, because that's our first term, times 1 minus 5 to the, well, we don't know which term this is, so we have to use n, over 1 minus 5. Well, 1 minus 5 is just negative 4. So if we were to, I keep trying to slide my paper up and it's marking on the page. If we were to multiply both sides by a negative 4, that would clear that denominator for us. Oh, there we go. Now that's just sliding that up. Awesome. Still learning this program. Okay. So negative 4 times 3,906 is going to be negative 15,624. And that's going to be equal to just 1 minus 5 to the n, because we have cleared our denominator. So let's subtract 1 from both sides. That gives us negative 15,625 is equal to negative 5 to the n. Well, we can just multiply both sides by a negative 1 to clear those negatives. And then it gives us a positive 15,625 equaling a positive 5 to the n, which is good, because when we want to solve for a variable, when it is in the exponent, we need to use logs. So I have a constant on one side and a exponential on the other side. So I'm going to take the log of both sides of the equation so that I can move the n out front. You can certainly use log base 5 if you have a calculator that will allow you to do so. I'm going to go ahead and treat it with log base 10. You can also use natural log. That way all of us have the same type of calculator. So I'm just going to do log base 10. So our power rule says that we can now bring the exponent out front. So I have got log of 15,625 on the left is equal to n times the log of 5. So I can just divide both sides by the log of 5. And that is going to give us an n value of 6. Be careful when you're entering into your calculator that you are closing parentheses appropriately. Consider the following geometric series: negative 60 plus 20 plus negative 20 over 3 plus 20 over 9, etc. Find the sum of the first 5 terms. Okay, well, we need to determine what r is. So r we can find by doing 20 over negative 60. That gives us negative 1/3. And then a sub 1, of course, is negative 60. So using our equation, S sub n equals a sub 1 times 1 minus r to the n power over 1 minus r. We're looking for the first 5 terms. A sub 1 was negative 60. And r is negative 1/3. Make sure we're careful with parentheses. It needs to be raised to the 5th power because we're looking for the sum of the first 5 terms. You can stick that into your calculator and you get, I think, about negative 45.1852 when we get done with that. All right. 2 more examples. So consider the geometric series 12 plus 36 plus 108 plus 324 and find the sum of the first 5 terms. So we have that S sub 5 would be equal to, well, 12 is the first term. 1 minus r would be found by doing 36 divided by 12, so that's 3. So 1 minus 3 to the 5th over 1 minus 3. 1,452. So now we're going to find n such that S sub n is equal to 354,288. So we're using the same equation. We're going to go ahead and put in our sum value for S sub n, so 354,288 is equal to 12 times 1 minus 3 to the n over 1 minus 3. So 354,288 is going to be equal to, well, 1 minus 3 is negative 2. 12 over negative 2 gives us negative 6. And then 1 minus 3 to the n. I'm going to go ahead and divide both sides by the negative 6. And we get negative 59,048 is going to be equal to 1 minus 3 to the n. We are going to subtract 1 from both sides. That gives us negative 59,049 is equal to negative 3 to the n. We know that we can multiply both sides by a negative 1 to make those positive. And then we're going to be using logs again. So you can use base 3. I'm going to go ahead and use natural log this time. That allows us to bring our exponent out front. Then we can divide both sides by the natural log of 3. And when we put that in our calculator, we are going to get an n value of 10. Now, n is always going to be an integer because these are position numbers in a sequence, or the number you're adding up to, and it basically is counting whole things. So if you ever work one of these problems and you get a decimal, you probably have an arithmetic error somewhere. Last example, find the sum of the geometric sequence. So this has been put in summation notation, which you have in your calculator under math. And so remember, the E just means add. And so for this, it's already telling us that n goes from 1 to 40, right? So we have n equals 1 to 40. So we're adding up the first 40 terms. So we want S sub 40, right? In all of these equations, we've been multiplying by a sub 1. So this 5 is a sub 1. That makes 3/5 what our R value is. Be careful with parentheses. It's 3/5, the whole thing to the n power, over 1 minus 3/5. We put that in our calculator to get the total sum, and it ends up being 12.5.